Good morning, everyone. Welcome to day 2 of our MCA review. Today we're talking about square roots and rational and irrational numbers. So I want you to get out your formula sheet from your folder because I want you to add something to this formula sheet on the side. I want you to add these perfect squares and the square roots that go with them. So it says the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on all the way to 12. Those will be things that will help you today to know that what those square roots are. So I'll give you a second to get those put on your sheet. You can pause the video if you need more time. Alright, so we're going to talk about some definitions of square roots, rational and irrational numbers. So real numbers are all the numbers that we deal with in calculus. So every number that we deal with in this class is a real number. Now rational numbers are whole numbers plus all the numbers that can be written as fractions. They either terminate or repeat. So if we had a decimal like 0.5 or 0.55 repeating, that would be a rational number. Also perfect squares. So all these perfect squares would be a rational number. Irrational numbers are numbers that do not end or repeat. Rational numbers are numbers that do not end or repeat. So they are non-perfect squares. So a number that wouldn't end would be like 0.5, 6, 1, 2, 3, on and on forever. Non-perfect squares would be like the square root of 17 or something like that. Something that's not a perfect square. Integers are negative counting numbers, 0, or positive counting numbers. So integers are the numbers that you could count on your finger. Whole numbers, they start at 0, and they are the positive counting numbers. So they would go from 0 to 1, 2, 3, 4, and so on. So we are going to simplify the square root here. So the square root of 36, well, I know that 36 is a perfect square because I know that 6 times 6 is 36. So the square root of 36 then is 6. Now 64, that's also a perfect square. I know that 8 times 8 is will equal 64. So what I'm going to have is 8. And then we have a negative out in front, so I have to include that negative, so it's a negative 8. Here we have to simplify two things. So it says the square root of 4 over 25. Well, 4 and 25 are both perfect squares. The square root of 4 is 2. The square root of 25 is 5. And then this last one is another perfect square, square root of 81. That's 9. Alright, so now it says between what two consecutive integers is the square root? So for these ones, this is not going to give us, if we did put this into our calculator, it's not going to give us a nice number. It's going to give us an irrational number. It's a number that repeats on and on, or it doesn't repeat, but goes on and on forever. We need to figure out what two consecutive integers is the square root. So I need to figure out what are the two perfect squares that would go here and go here? So one before and one after 41. Well, I know the perfect square before 41 is 36, and the perfect square after 41 is 49. So the square root of 36, well, that's 6. Square root of 49, that's 7. 6 and 7 are consecutive integers. So our answer would be 6 and 7. here the square root of 1 comes before 2, and the square root of 4 comes after 2. So the square root of 1 is 1, the square root of 4 is 2. So it comes between 1 and 2. The square root before and the square root after, well, I know the square root after is 144, and the square root before is 121. So the square root of 121, that's 11. Square root of 144, that's 12. So between 11 and 12. Okay, what comes before 23? Well, that's 16. After 23 is 25. So the square root of 16 is 4. Square root of 25 is 5. But remember, we have this negative outside, so we just got to add that to our our 4 and our 5. So it's between -4 and -5. Now, comparing real numbers. When we compare, we need a less than sign, greater than sign, or less than or equal to, or greater than or equal to. So the square root of 8, well, 8 is not a perfect square, so what comes between, square root of 8 comes between the square root of 4 and the square root of 9. So I know that's somewhere between 2 and 3. Well, I know that 4 is already bigger than 2 or 3, so I know that the square root of 8 is less than 4. Here, the square root of 10, well, the things that come around that are 9 and 16. So that's between 3 and 4. So it's somewhere between 3 and 4, so that means it's greater than 3. So 3 is also less than the square root of 10. Alright, so now we need to label these numbers as real, rational, irrational, whole, or integer. Now it says a little note up here, make a table. That's going to be the easiest thing we can do. So I'm going to make a table here. We're going to have the square root of 3, 5.5, the square root of 16, the negative square root of 16, and 0. Now we're looking to see if it's real, rational, irrational, whole, or an integer. Now it could be multiple of these. It doesn't have to be just one. Now, if I go back to here, I see that real numbers are all the numbers we deal with in calculus. So all of these are going to be real. Every number we're dealing with right here is, well, we're dealing with it. We're not in calculus, so it's a real number. Rational. Rational numbers are whole numbers plus all the numbers that can be written as fractions. They either terminate or repeat, or they're perfect squares. So 5.5, that terminates. That's a rational number. The square root of 3 is not a perfect square, so it can't be rational. 16 is a perfect square, so that can be rational. And 0 is also something that we can count, so it's going to be rational. Now the square root of 3 is not a perfect square. Irrational numbers do not have perfect squares, so that has to be an irrational number. If it's irrational, it can't be anything else, so we've already completed for the square root of 3. 5.5, is not a whole number because it's a decimal. It's also not an integer because we can't count it. Integers are numbers that we can count. Now the square root of 16 is really 4, but then we have a negative. So if we look back, whole numbers start at 0 and they are positive counting numbers. Well, this is a counting number, but it's a negative 4, so it can't be whole. An integer, though, are negative counting numbers, 0, and positive counting numbers. So it could still be an integer, which it is. 0, well, does a whole number start at 0? Yes, it does. So it is a whole number. It's also a counting number, so it's also an integer. Alright, now we need to order these from least to greatest. So what I'm going to do is I'm going to start by just writing them out a little bit longer than what we have. So we have 0.47 repeating, which would be 0.47777, and on and on and on forever. Then we have 0.474 repeating, which would be 474, 474, 474, constantly on and on forever. Then 0.47474747 repeating. And the square root of 0.23. So this is probably going to be one that you grab your calculator for. So the square root of that gives us 0.479583152 on forever. So which one of these is smallest? Well, I'm going to look at, I see they all start with 4s. They all have a 7. The next number comes 7449. So I know it can't be the first one, it can't be the last one. So I got to look at the next number. It goes from 4 to 4, 4 to 7. 4 is less than 7, so I know that this one has to be the least. So that's 1. Then, next one has to be the 7. Now I'm looking 4, 7, 4, 7, 7, 9. So 7 is less than 9, so this has to be the third. And then this would be the fourth.